Hello, this is going to be a slightly different video. I tried recording twice on my Mac. Unfortunately, my Mac has a few issues at the moment with trying to record this, and QuickTime went for a major crap. So I'm going to record this on my Linux machine with OBS, and then I'm just going to do a standard edit on here. But I wanted to make a quick video to show that I've kind of more or less finished version 1.0 of my Earth clock project that I wanted to make. And I've already committed the code to GitHub, but I'm also going to make the binary available. So check the description below. It's just a standard Java application, so you should theoretically only need to install the Java runtime environment. So I've added a few features that I kind of wanted to add since I started this. And I'm going to start with the speed control. So there are various speeds available, and if you go 1 frame per second, it's going to advance the second hand, kind of like a quartz clock, where the quartz clock ticks the second hand once every second. There is another mode where you can step ahead up to 60 frames a second. And I wanted to add this to create a relatively smooth clock like this. And if you'll notice for a second, the second hand is going to stop, and then the minute hand is going to jump as the second hand starts up again. This was something that I implemented based on David Weiss's Flat Earth Clock app. If you look at how that clock works, the second hand moves smoothly like that. And when the second hand reaches the very top, then the minute hand advances by a 1 minute increment, like this is going to do here shortly. I was wondering what kind of clock that was like, and I did a bit of research and I could not find anything that would simulate the kind of mechanical movement that David Weiss's Flat Earth Clock app emulates. The closest that I could find was the Swiss railway clock that this emulates. Back in the 1940s or the 1950s, I think, Swiss Railway wanted all of their clocks to show the exact same time at all of their stations. And so the way that they did that, they used a synchronous motor to drive the second hand so that the second hand was just a little bit faster than 1 revolution per minute. So that would mean that it would go from the 12 o'clock position back to the 12 o'clock position in only 58.5 seconds. Then there was a mechanism that would stop the motor from turning until it received a signal from a central time authority, and when it got that signal, then it would resume the second hand. But I think also part of that, and I didn't do too much research into that, but I think that the minute hand and the hour hand were driven by a separate mechanism, and it might have been by a solenoid. So when the central clock device sent a signal to all of the clocks in all of their stations, that clock that received the signal would close a solenoid, and when that solenoid closed, I think that's when it would ratchet the minute hand ahead by 1 minute. And I think that's the way it worked. So I tried to recreate that kind of look with the Swiss railway style clock like this. And if you uncheck that, and I'm just going to wait a second just for the fun of it. So if you uncheck that, just to visually distinguish that it's no longer the Swiss railway clock style, I just have this little dot that moves around the perimeter of the azimuthal equidistant map, which represents the second hand. And later on, I could maybe create a separate image for the second hand. I might do that for the next version. If you advance by minute, it's not going to advance the seconds, but is going to advance the minutes. You can advance by hours or by days. And you can see that the moon is circling around and that the sun is moving towards the Tropic of Cancer. You might notice that this computer is struggling to render the images quickly, and I think it's because the setting that I have is not using the proper video driver, or it may not be using hardware acceleration. If you go per second like this, most computers should be fast enough to render it, even without hardware acceleration. You can stop the timer, so it'll basically freeze the clock at whatever time that it happens to be set to. And if you turn the timer back on, it will resume. This version will save the current settings into a properties file. As you keep changing the settings, it'll update that properties file. So if you close the app and restart it, it will go back to the last settings that were used. I'm doing a test right now with a brand new installation so that hopefully I've got all the files required, and it defaults back to null island, so latitude 0, longitude 0. I can change that to my location. So the next setting that we have is the 24-hour style clock. As you can see, the sun is along the hour hand. If I choose a standard 12-hour style clock, then the hour hand is going to go twice as fast as the sun, and that it will only line up theoretically when the sun passes your local meridian. I kept the Mickey Mouse face that I had implemented in the previous versions, and that is the default. I may describe how you could go about implementing different clock faces, but that was another goal that I wanted. Those are essentially done by loading different PNG files for the various layers. I borrowed the zenith angles layer from the other code that I had, and as you can see, the computer is really starting to struggle now a little bit more as it's trying to render those lines. These lines represent 15 degrees of zenith declination. This would be 75 degrees altitude. This would be 60 degrees of altitude, 45, 30, 15. If you are standing anywhere on this yellow line, the sun would be at the horizon. The black lines represent where the sun would be below the horizon, and not where the blue dot is, but right around here, which I don't display in this one. That would be the antipode of the sun. The other option that I have allows you to do a partial opacity of the day-nights. I'll just turn off the zenith angles to speed things up a little bit. Here we have 3 different bands of twilight. The first is the civil twilight. Second band I think it's the naval twilight. And the third one I think is astronomical twilight. And then finally, this last part is where there's no light in the sky at all, except for maybe the moon and the stars. You can do a full opacity, which will make this part completely pitch black. And that is how it would look in reality. Or again, you can turn it off. And the last mode that I added was something that I thought other YouTubers might find useful if they wanted to have some kind of background animation, particularly the ones who make videos against the flat earth, and maybe they want to poke fun at the flat earthers by using this map. If you go full screen, it's going to obviously go full screen, but it's also going to hide the menu. And so you could then capture that window in whatever software you're using, or maybe project the output of this program to a monitor in the back or something. And if I had a computer that could run it at a reasonable frame rate, I would probably choose this setting here. So once again, check the description below. You should find some links both to my GitHub project and where you can get a copy of the binary. I would be interested to know how it works on other computers, like maybe Windows. So that's really going to be it for now. Thank you for watching. And if you're not subscribed, I would appreciate if you did. And please leave comments below what you think of this whole Earth clock project. And thank you for watching, and I'm going to see you again in another video soon enough. So bye for now.